Section 14.2, transformations of trig graphs. Previously, we only did a basic trig graph like y equals sine x, y equals cosine x, y equals tangent x. Now we're going to look at what happens if you shift them right, left, up, down, or stretch them vertically or horizontally. There is one equation that will describe every transformation for sine, and it works very similar for cosine, so we're just going to do the sine version right here. And here it is. Here's like your master formula for everything. Y, everything fits in this form. Y equals A sine B is the second kind of transformation times X minus C is another kind of transformation, plus D is the fourth option. And so let me describe A, B, C, and D. And then we'll have everything, and then we just look at one thing at a time. So A is handy because that stands for the amplitude, which also starts with an A, which is very nice. Amplitude. And so you basically take the absolute value of this constant A, and that will give you the amplitude, and that is like the wave height from the middle to the top. And so that gives you, and a little picture would be this way. That tells you the highest and lowest point. So it's like your vertical stretch or shrink is the amplitude of the wave, stretch or shrink. So if the number is small, you are shrinking it down, and if it is big, you are stretching it, and you'll see. That's called the amplitude. It tells you the amplitude. A is not the amplitude, it's the absolute value. So even if A is -3, the amplitude is just 3. Okay, B is if you want, like for example, higher pitched sounds have a higher frequency, like some that only dogs can hear. So B helps you determine the frequency of the wave, and that is basically tells you this way, are you stretching or shrinking? So it's the horizontal. Okay, horizontal means, you know, that way. Are you like remember the slinkies? They stretch or compress a slinky. Do you know what a slinky is? Yeah. Okay. I need to get one. Stretch or shrink, and so the period of which we have talked about, we know the period for sine and cosine is 2 pi, right? But depending on what B is, you would divide by B, and that would either make it bigger or smaller. So the bigger the frequency, the smaller the period, because it repeats more often. Okay, and then C, it stands for what you're used to. You've seen this with parabolas and with other graphs. It shifts right or left. It just takes the whole thing and shifts to the right or left. If C is positive, it's to the right. If C is negative, it's to the left. You are used to that. You've seen it since the beginning of the year. And D is the same as what you're used to. D is the center of the wave, and it moves it up or down. This is the center. I'm going to use the formal word. It's the wave axis. It's the center, wave axis, or center. And that moves it up or down. You're used to that already. Nothing different. Why? Because you're adding some constant. So of course it would move it up or down. Okay, so those are all 4 possible transformations. Now to start out, we're going to look at only one at a time, and then we'll put together a couple, and by Friday we should be able to do, hopefully we can do all 4 at the same time. But there's a procedure that you follow that will take care of it. So examples, we're just going to do examples now. And we're going to only graph one period of each example. You can always repeat it. So whatever it is, we're going to graph one period. And we're going to do 5 examples together. So number 1, y equals 3 cosine x. Okay, so let me show you the procedure. You'll get used to it. We're just going to do one period. So you're going to just make your xy axis, and we're going to scale our axes, and then we'll be fine. So we're going to start with the y-axis. Here, a is 3. That's the only thing different from our basic graph. So in this case, the amplitude equals the absolute value of 3, which is just 3. So what that tells us is normally our maximum and minimum is 1 and -1. Now what's it going to be? 3 and -3. So we're going to just go, our highest point will be 3. Our highest point will be 3. Our lowest point will be -3. And now we're done scaling the y-axis and labeling. So if you watch, it'll be so easy. You just do the outline first, and then you plot the 5 points, and you're done. So then on the x-axis, we're only doing one period. The period has not changed. The period is just the default, which is 2 pi. So we're going to go out to 2 pi, because we're only going to sketch one period. Then you're going to, if you go out to 2 pi, you cut it in half. Half of 2 pi is pi. And you cut that in half and that in half. And I won't even require you to label them. Just that you have those 5 points. And now watch. This is the easy part. Once you get that work done, cosine. Okay, we're dealing with cosine. Does that start at the highest point or at the middle? The highest. So you watch how easy this is. You go high, because there's a pattern. High, middle. There's only one place to go. Low, middle, high. So here's your shape. Make sure it's a nice curve. And I'm done sketching. I'll put arrows on the end to make sure you know it keeps going, and that's one period of cosine. So there questions? Cosine starts high, middle, low. There's only one place to go. You can't really mess up if you get the outline right. And notice I'm not even thinking about the unit circle, about what the specific values are, because I'm past that. Okay, example 2. We're going to do y equals 1/2. Y equals 1/2 sine of x. So we go, we're going to scale the y-axis first, so that we just always do the same thing. What's the amplitude? Is 1/2. It's the absolute value of a, which is 1/2. So our highest point is 1/2, so I'm going to put that a little bit lower so that it looks, I can compare it to my others. So you're basically compressing it vertically because the amplitude is smaller. So the magnitude of this wave is smaller. Everything else is the same. So you go out to 2 pi because we're doing one period. The period has not changed. Half of that is pi. And then you cut that in half and cut this in half. So we're ready to sketch. Now sine, does it start at the highest or at the middle? The middle, which happens to be 0 right now, but that's going to change later. So you as long as you start at the right place. And does sine go up or down? When we were graphing the basic, it always has gone up, right? So you start at the middle. So watch, middle, high, middle, low, middle. middle, high, middle, low, middle. And a little arrow to show it keeps going, but that's one period, and the amplitude is smaller. It's cut by a half. Number 3, let's try, now we're going to change something else. Y equals sine of 4x. It's only, but notice we're only doing one transformation at a time. So in this case, we're going to scale our y-axis first. What is the amplitude? Yeah, the amplitude, it has not changed at all. The amplitude is 1. There's an invisible 1 in front, right? So compared to the original, A is 1, the amplitude is still the same. So we're going to go, the highest is 1, the lowest is -1. And the period now, go back to your formula, okay? The period is 2 pi over b. What is b? 4. So the period is now pi over 2. So it's a fourth what it usually is. That means it's a more frequent wave. So if we only do one period of this, we would go to pi over, this whole thing will happen in pi over 2 time. So we're going to scaling the x-axis, okay? You go out one period, which is pi over 2. It's not very far. Then you cut that in half, which is pi over 4. Good. And now there isn't even room to label the other points, but you have to cut that in half and cut that in half. So it happens very rapidly. So you go, okay, we're ready. We have the outline. You getting the picture? You scale the axes, you have the outline. So sine, does that start at the highest or the middle? Okay, so go middle, and then sine usually goes up or down from there. Up. So middle, high, middle, low, middle. So it's like, I can just hear it, like it's a higher pitch, happens more frequently. And that's one period, okay? It would be more interesting to go out actually to 2 pi, and then you would see it, more of the wave, if you kept going. If you kept repeating the periods out to 2 pi, you could compare to the previous wave, and you would see that it just happens, you know, more frequently. Okay, so let's try number 4 is y equals cosine of a half x. So what's the amplitude? 1. The period is 2 pi over a half. When you divide by a fraction, it's the same as multiplying by the reciprocal. So we're multiplying by 2, we're doubling it. Dividing by a half is doubling. So 4 pi. So now it's like going to take longer. The period, it's going to take 4 pi just to get in one period. So on the y-axis is still, the highest is 1, the lowest is -1. Here we have to stretch this out. We're stretching it horizontally out to 4 pi, all the way out to here. So 2 pi will go in the middle. And why not label them? There's plenty of room. Half of 2 pi is pi, and this is 3 pi. So we're ready to look at this, stretching it horizontally. So cosine, but careful, before you start, the cosine starts in the middle? No, it starts at the highest. So you have to start here, otherwise everything gets screwed up. High, middle, low, middle, high. So it's this stretched out wave. It takes all that time. It moves very slowly. The frequency is only a half. So it stretches it horizontally. And now we're going to do one last one for this segment that does two things at once. It changes the amplitude and the frequency. So we're on last example for this section. So we're going to do y equals 3 cosine of 2x. So y equals 3 cosine of 2x. So the amplitude is very good. The period is You have to do the math there. 2 pi over b, so it's just pi. So now we have to scale the x and y axis. Let's always start with y, since that's what we've been doing. So this is a very high, it's a high wave. So that, because the highest is 3, we have to go all the way up to 3 and all the way down to -3. So it's a high wave. The period is more frequent because the frequency is 2. The period is pi, so but we're only doing 1 period, so we'll go out to pi. We'll cut, you get the idea, right? Cut it in half. Good. And cut each of these in half, because I always need 5 very clear points. And where do we start? Cosine. Highest or middle? Highest. Cosine starts at the highest, so we go high, middle, low, middle, high, high, middle, low, middle, high, and a little arrow to show we keep going. And that's great because so it's a taller wave, the amplitude is higher, it's more frequent, so that makes sense that it looks like that, at least 1 period of it.